Our topic for today is binomial products. Now, if you haven't heard this phrase before, products just simply means multiply. Product is the answer to a multiplication problem. Binomial, bi is two, nomial refers to numbers. So, we've had a rule before when we were doing algebra and so on for expanding brackets. Whenever we had two sets of numbers multiplied by each other, something like a plus b, c plus d times c plus d. And we used a process called FOIL, first, outside, inside, last. And what FOIL means is first, outside, inside, last. We multiply the first two together. We multiply here. That gives me AC. We multiply the outside two together, which gives me AD. We multiply the inside two together. That gives me BC. And we multiply the last two together, which in this case gives me BD. You should remember this from binomial products with something like this. 2 plus x times 3 plus z. And we can multiply them together. And let's assume instead that we actually had two pronumerals that were the same. So let's actually use x here. FOIL would give us the first two, which was 6. The outside two, 2 times x is 2x. The inside two, 3 times x is 3x. And the last two, which would give me x squared. And we can simplify the two in the middle to 5x. Now what we're dealing with today is doing the same process with surds. So let's use an example of a surd that we wanted to do this with. Let's try 4 plus the square root of 3. 4 plus the square root of 3 times the square root of 3 minus 2. Now we're going to do the same process. We're going to say the first two, 4 times root 3 is just 4 root 3. The outside two, 4 times, remember it's a minus 2, the minus stays with the number that follows it. 4 times minus 2, minus 8. The inside two, root 3 times root 3, which is just 3. Square root of 3 times the square root of 3 is 3, plus 3. And the last two, root 3 times negative 2, no root involved, well there is, but minus 2 times root 3 is this. And then we can simplify it when we're done. So we have 4 root 3, take away 2 root 3, gives me 2 root 3. And minus 8 plus 3 gives me minus 5. Let's use another slightly more complex example. Let's try 2 root 5 minus 1 times root 5 plus 4. We're going to use the FOIL process on these. So we're going to say first two, 2 root 5 times root 5. I'm going to have you do that in your head. We multiply the numbers together, we get 2. Multiply the surds together, root 5 times root 5 gives me 5. 2 times 5 is 10. The outside two, 2 root 5 times 4 gives me 8 root 5. The inside two, minus 1 times root 5 gives me minus root 5. And the last two, minus 1 times 4 gives me minus 4. Again, I can simplify. 10 minus 4 is 6. And I have 8 root 5, take away root 5, gives me 7 root 5. Now, you may also remember that when we're dealing with binomial products, there are several that are special that allow us to save some time as we work through the process. One of those is what we call perfect squares. And it works like this. I have a plus b squared, which is just a plus b times a plus b. Then imagine that I've rewritten that. I'm not going to, because I want you to be able to do this in your mind. A plus b times a plus b. If I were to do FOIL with this, then what would I get? A times a, the first two, gives me a squared. The outside two, a times a plus b, so a times b, or the same as a times b there, gives me ab. And then the inside two gives me b times a, which is also ab. And the last two, b squared. And you'll notice that these two terms are always the same. So the short way to think about this product is we square the first one, a squared. We multiply the two terms together, ab, and double it, 2ab. And we square the last term, which is b squared. And the same will work if we have a minus in the middle. It's just slightly different. A minus b squared. Again, we multiply these two together. This by itself, we get a squared. We multiply the two together, so we get negative ab, because it's a times negative b. And we multiply by 2, which gives us minus 2ab. And then at the end, minus b times minus b, which gives me a positive b squared. Again, we can use this same principle with surds. So let's take, for example, 2 minus the square root of 7, quantity squared. Same process applies. 2 squared, 4. Then we multiply these two together, so we get negative 2 times negative root 7 gives me negative 2 root 7. And I multiply by 2, which gives me negative 4 root 7. And then I multiply this times itself for the last one. Negative root 7 times negative root 7 gives me 7. And I will often be able to simplify, in this case just these two, which gives me 11. 4 plus 7 is 11, minus 4 root 7. Same thing works with slightly more complex ones. Let's say, for example, 3 root 2 plus 5 root 3, quantity squared. Again, I multiply this times itself, I square it, which means 3 root 2 times 3 root 2. Multiply the numbers together, 3 times 3 is 9. 9, I'll write it here for a second, 9. Root 2 times root 2 is 4. So, excuse me, root 2 times root 2 is not 4, it's 2. So I get 18. Now I'm going to multiply them together. So 3 times 5 is 15. Root 2 times root 3 is root 6. And then I need to double that. So when I double that, I get plus 30 root 6. And then I square the last one, which gives me 5 times 5 is 25. Root 3 times root 3 is 3. Which gives me 75. And again, I can simplify by adding these two together, and I get 93 plus 30 root 6. Now the last shortcut that I have is called the difference of squares. It's sort of like these. But what makes it different is where with the perfect squares, I have a term in the middle that's doubled of those two terms multiplied together. I also have one that looks like this, a plus b times a plus c. Excuse me, a minus b. A minus b. And the way this works, if I apply FOIL to it, it'll still work the same way. A times a is a squared. Outside, a times b minus b is minus ab. Inside, b times a is plus ab. And b times minus b is minus b squared. And what you notice is these two terms are the same, these two terms are the same, but the sign in the middle is opposite. So what will always happen when we do one of these is that the middle term will cancel each other out. The two middle terms will cancel each other out. And we are just left with a squared minus b squared. So when we see this form where we have the same term, and the signs in the middle are different, then we know that this middle term that we would normally have will cancel itself out. And we're just left with squaring the two on the end. A squared minus b squared. A squared minus b squared. It is important that we realize it's a minus in the middle. How does this work with surds? The same sort of a way. We just don't have to worry about calculating that middle term. That's the beauty of it. So let's try something like this. 2 plus root 5 times 2 minus root 5. Now again, these are the same, these are the same, signs in the middle are different. So all we have to do is multiply these by each other. 2 times 2 is equal to 4, and it's a minus, and then root 5 times root 5 is equal to 5, which we can simplify nicely to minus 1. Even with more complex surds, we can still do the same thing. Let's try 7 root 2 plus root 3 times 7 root 2 minus root 3. Again, you notice these are the same, and it's plus and minus in the middle. So we start with squaring the first term. Now let's do that by hand first. 7 times 7 is 49. Root 2 times root 2 is 2. 49 times 2 is 98. And then the other one, and of course we have to have a minus in the middle, and the other one's easy. Root 3 times root 3 is 3. And we can simplify that to 95. And that is how we do binomial products.